Yeah, so that's the thing. When I decided to come to Scala-Italy, I said, okay, that's the moment that I make a revelation to the Italian Scala community. And I learned a sentence yesterday, but Ivano just tell everybody. But I will say anyway. So someone told me that I should come here and say, "L'importace, io non sono italiano." So it seems that worked out the way it was supposed to. So the funny part is that although I have a very Italian name, I'm not at all. And it happens very often that people come after a talk in Italian to me, and I think there is at least 10 people in this room that have done that. And and I used to say that each time that I do a talk, but I think that now that I told all the Italians in the Scala community, I don't have to do that anymore. So last time that I bring that subject. So as Ivan was saying, I work in Lagon. So the Lagon team and the play team now is fusioned. So we call just the play team. I'll not talk much about play and Lagon, but I will talk about Akka persistence typed, because it has some relation to Lagon. And as Ivano was saying, I'm pretty much into event sourcing, CQRS, and so on. So Akka persistence type is close to my heart. So first, a little bit of story about Akka persistence. So it started with, I forgot to put my timer. Anyway, let's see. So it started with an Akka extension created by Martin Krasser. And I think that the first commit on his GitHub repo is from 2012. And it was called event sourced because it's about event sourcing. It's not just general persistence, but about how to persist the state of your actor using event sourcing. Then later it was integrated into Akka itself, and then it became Akka persistence. And I think the first release that was not experimental anymore was in Akka 2.4. In Akka 2.5, Akka persistence query was introduced because because sometimes we need to understand the difference of event sourcing and CQRS. So CQRS means command query responsibility segregation, and you can have event sourcing without doing CQRS. It's just about saving the state of your object by persisting events that you can replay and reconstruct the state. That is event sourcing. And that was there in Akka persistent. But it was not easy to consume the events from the journal. The first consumer of those events are the actor itself. When you instantiate it, it goes to the journal. It reads the events for him, for his idea, and you replay those events and reconstruct the state. So the first consumer is always the model that saves those events. But then later you also want to take those events and use it to generate views, to push into Kafka so other systems can consume your data and so on. So for that you need the query. So the Akka persistence query is together with the persistence part, the event sourced part, is what will allow you to build CQRS applications using Akka. Now, Akka typed is coming in 2.6, and of course there is also a persistence typed API, and that's what I'm going to show today. So just, there is a tick there. Anyway, the examples I will show today is based on Akka 2.6 milestone 7. The code still may change. I know there is a PR in flight that will change some stuff in Akka. So I think in a week we'll have milestone 8, if I'm not mistaken. So just that you know that if you later take the presentation and you go try the code, can be that one method change the name slightly and so on, this kind of stuff. But before I start with Akka persistence typed, I just want to give a quick overview of Akka typed, so you understand what is going on. So I like to ask, just to have an idea, who use Akka Okay, pretty much a little bit more than half. And who use Akka persistence? Okay, much less. Okay, good. So, I will assume that you are more or less familiar with Akka. And so when you define a message in Akka, and now I talk about untyped, it can be any message. You can send any message to your actor. But in typed, you have to define your protocol. And you need to have a trait, let's say, which is your main type. In that case here is just message. And then you can have variations of that, and those are the messages that you can send to your actor. So you start by defining this protocol. Then in Akka typed, you don't have, at least the Scala API, you don't extend an actor. What you do is you define a behavior, and the behavior is basically a function from the message types that you can send to that actor to the next behavior. And while processing that function, you can do some work, and then when you finish, you tell the actor system, okay, I did what I had to do, here's my behavior for the next message. So that's how you basically work. This example is, of course, extremely simple, and because it's a function, you don't have a state that you can put in your actor. So when you do Akka untyped, you usually, if you need some state, you create a var, and it's safe because the actor system will make sure that there is not possible to have two threads changing that var. But in Akka typed, you even don't have that. So here the state is actually brought into the scope of my function by the behavior method. You send the greeting. So here we're going to say ciao, and it's the state of this behavior. And I can change it. So when I send a message change greeting, I change it to something else, like hello. And you see that the behavior here, yeah, he's here. You see that the behavior, when I send the change greeting, it changed the behavior to the next message, to the next greeting. But because you have this function, you don't have the means to do actor stuff like before. Before you had to implement an actor, now you have a function. So how can I log? Before I could implement actor logging, but in Akka typed, I can't. So what you do is you wrap your behavior, you wrap your original behavior into another one that will bring something into your context. That will bring a context into your scope. And then you can log, for instance. That's just a very simplified example, just so you get the sense of how it works. Last thing about Akka typed that is different, and it's, to my opinion, it's a huge improvement, is that you don't have the sender anymore. Because before you had the sender method in your actor, but again, you're not extending an actor. So, and you also don't have the sender in any form, also not in the context, in the actor context. So what you have to do is you have to put in your message an actor ref of, in that case here, of hello, which is the answer. And you have to, when you say hello to that actor, you have to say, okay, and I want an answer on that actor ref. And that's how you, so the fact that you are requesting a reaction from the actor to send you back something is in the protocol itself. So you have to encode it in your message. And as you see here, I take the hello, and then, I take the hello, I take the reply to, and I send a message back to it. When you are outside the actor system, and you do a ask to an actor, the ask method, now it gets a function from reply to actor ref of hello, in that case, to the message that you're sending. So so the ask will fabricate an actor ref of this type, so it can be passed here. And what will happen is that when you send a message to that actor ref hello, it will complete the future that you get back here. And now, when I do an ask, I know exactly what is the future that I get back. I know the type. I don't have to map it to a type, like it was the case in untyped. Okay, Akka persistence typed. So, like in Akka typed, you have to start defining a protocol. But in Akka persistence, you need to define three parts: the commands, which are the message that is sent to your actor; the events, which are the message that you're going to persist, so the data that you're going to put in your journal; and the state itself. This time we have a state that was different than the one in the previous example. That was just the state was something in the scope of a function. Here you have to define a state, and we'll see how it will look like. Because it's a special kind of actor, and it will behave different than other actors. Well, the major principles of actor is still there, but it's an extension of it. Let's see how it looks like. So you not define a behavior, but you define an event-sourced behavior. And then we find back the name, the original name of the extension that was before called it event-sourced, with lowercase s. Now the name came back. And I think it's also a good change, because it makes very clear to users that this is about event sourcing. One thing that in Akka typed, Akka untyped, you can tag your events. And why you do that, in principle, for your actors, that's not important. But you want to tag it so you can query it. So outside, not your actor, but the consumers of your event, of your journal, you want to select events that have received a given tag and then do something with that. So tagging is important to allow query, and it was there. But you had to define an event adapter, put it in a configuration file, because it was something that was happening low in the Akka persistence API. At some point, you have to read that event adapter when an event is about to be persistent and see if it has to apply a tag or not. But now it's part of the event sourced behavior. You just discover that by doing code completion, and you see directly the function. So it's more declarative, and it's also an improvement. There are many others. I will just highlight the most important improvements for building event-sourced applications. No? Another thing that is also better, for me it's a huge improvement actually, is you have better control of the snapshotting. So snapshotting, if you're not familiar with event sourcing, is that you keep adding events in your journal, and at some point you save the current state of your model. And if tomorrow I need to reinstantiate that model, I will not replay the events from zero, but I will start with that snapshot, and then I replay the events that happen after that. What was the problem in untyped is that the untyped was a very procedural API, and you could choose when to call the snapshot method. You had to do that. You also had to not forget to apply the event, for instance, to mutate your state, and you have to be conscious that you should snapshot your data, your state, after you apply the event, not before. And people made mistakes like that. So now it's not the case anymore, it's declarative, and you're gonna tell Akka when you want the state, the snapshot to be taken, but you not do that yourself. You just tell the conditions, and Akka will do for you. So for me, it's a huge improvement. Then there is the enforced replies, and I will not talk much about that because I have a live coding session, because then I prefer to expand there. But then it's a new concept that will help you deal with replies. And in the live coding, I will show how it looks like. Important is old plugins are still there, are still compatible. There is nothing to change. If you're using Akka persistence with JDBC plugin of Cassandra or any other plugin, don't worry, it just works as before. So the new API is only the user level API that are exposed to the users. So the plugins, they just work as before. And the Akka persistence query is not getting a typed API because it was already typed. It's based on Akka streams, and when you do a query, you get a source, an Akka stream source, and you just consume that source, and it's already typed. So nothing changed there. Nothing changed there. Now, how are we going to define those commands and events and state? Well, just Scala classes, case class you choose, can be objects, case objects. You just define your, where is my, okay, it's over. Okay, I lost it. So you define your commands and have deposit withdraw, and I have a get balance, which is kind of read command. I'm not mutating that, but I'm asking for some data. So I took the account example because it's extremely simple and everybody understands how an account works. Of course, it's extremely simplified example, just for demos, okay? So I defined those three kinds of types from my protocol, the commands, the events, and the state itself. Then I need to define two things. The command handlers, what I will do when a command gets into my actor, and how I process the events. So this is a command handler, and actually it's a function from state, command, to effect. And I'll talk about the effect in a while. But before I want to mention something, I was talking with Sebastian yesterday, and I like very much when you have a keynote that bring an idea, and then it influences also the speakers that will come later on the conference and think about what they are doing, and does it match with the keynote or not? And so here's my contribution to, I want to link now to Sebastian's talk. And this, for me, it's a good example of how you can combine object-oriented with functional programming. And there are a few things here that, for me, it's important. First is that you are modeling your domain. And I think it's super natural to put the command handler, or actually the action that you take on that account, as a method inside that account. And but if we were in an object-oriented world, and I can tell that the Java API is different than the Scala in that respect, you have to implement something that tells Akka what is the command handler. So you are free to choose the way you model. You can choose object-oriented style of modeling, but Akka is not asking you, for the Scala API, to implement some interface so it knows where is the command handler. What Akka does, it defines a function, requests you to define a function from state and command to an effect. So you model the way you want, but then you make that bridge from the object-oriented port back to the functional programming world, and Akka is happy now. So as you can see, I have an account, and there is a command, apply command, and actually that fulfills the requirement of my function, but I'm doing object-oriented. So the effect. The effect is important, of course. It's not Katz effect, but it's about you declaratively tell what you're going to do, what you want to happen. In that case, very simplified, just say, I want to persist that. And you give it to Akka, and Akka will do it for you. There are other methods that you can compose here, like not compose, but add to your effect. So you first start saying, I want to persist, and then I want to do this other side effect or this other thing. We're going to see. The event handler is super simple. There is no effect. There is just your model. It goes from state and event, and you produce the next state. So you apply the event to your state, producing the mutation. Now, once you have them all, you're gonna give it to Akka, and you do it by defining an event source behavior. It has a persistence ID. It's typed, and I'll not go much into that, but there are some features there to help the plugin write the ID on the journal. You have to define your initial state account with 0 balance, and then you give the command handlers the event handler functions. And in that case, I'm using the object-oriented style and actually bring it in the function format so I can give to Akka. Now, tagging. It's not like an event adapter as before, but you can just go in your behavior and say, I want it with tagger. And you tell what is a function from events to a set of strings. So you tell what are the strings that we want to use as tag for each event. and you can declare what you want for a snapshot. Like the retention is about, in that case here, I'm saying every 100 events, please do a snapshot for me, and please don't keep more than 2 snapshots in the journal, in the storage. Or you can use a predicate, and you can combine both. You can say, I want a snapshot every 100 events, but also I want a snapshot when I get, for instance, withdraw event. So the function here is the state, the event that was persisted, and the sequence number of that event in your journal. And you decide you can use one of them to make a decision and return true or false. So let's do, I'm pretty bad in live coding, so don't laugh. Oh God, you make me nervous now. So here's the account command, account model that I was showing. Its size is good, okay. And just it's a little bit more elaborated. All commands have a reply to. If you send a deposit, the reply is always accepted, because you can always put money, especially my account. That's a hint. The withdraw, you need to decide if it's allowed or not. So there is a confirmation, and the confirmation can be accepted or rejected, and there is the balance that you can request. You cannot request the balance of my account in any case. And then you have the events. Here I declare them, and it's exactly the same as in the slides. And the apply events method is exactly the same. And the apply command is a little bit more sophisticated or elaborated. So, and here's what I want to show is that there is nothing, although I have now this deposit where I send a reply to, there is nothing here to force me to reply to you. So if I do that, I'm still compiling, because I'm returning an effect, but you cannot tell if I really took the reply to from your message and sent the accepted message back to you. So you can easily make that mistake. So let's see how I can improve a little bit this experience by using a variation of event source behavior, which is with enforced replies. And now my code is not compiling because my command is not of the right type. The enforced replies requires that my command has to extend this Akka type here, expecting reply. So I'm going to do that. And I'll say, now the live code starts. Oof. No, yeah. It's an account reply and extends expecting reply. When I trained myself, it was much better. So this one will send accepted, this one is confirmation, and this one is balance. But now I have to fix here, because now what I have here is copy and paste is better than live coding. I have to fix here. So I fixed the compilation at that level, but here is not compiling now, because this one is returning effect, but it should return a reply effect. And the reply effect, okay, let's go. Reply effect. But now it's not compiling yet, because I'm still returning the effect, not a reply effect now. So to go from an effect to a reply, I have to finish my series of operations with a conversion to reply. And how it looks like, I take here the command. I need to do that because I needed an instance. I need to have a reference to the command. And I will have to do then reply. I pass my command, so now it knows what is the command that's coming in and knows what is the type of the reply. And I have the states, which is actually the updated accounts. And that's important. I will talk about that. I won't use it for my reply, but I'm putting here so you get a feel of what that is. It's a function from the state to my answer. And now this is compiling. Let me just take here. That's also the same kind of reply that I want here. That's important. So here when I get a withdraw command and I see that I will go below 0, I will not accept that command. So I cannot, if I throw an exception, that actor will die, and the person that of the user of whatever the program that sent that command will not get a reply at all. So I cannot throw an exception. I cannot send an Akka failure as before. That was the case in Akka untyped. I cannot send an Akka failure to that reply because the reply is not a reply of failure. The reply is a reply. The reply to is an actor F of confirmation. So I need to send the type that is expecting. So I hope people will like that because it's we just say, okay, if the future failed, it's because there is a really issue. It's on you to have a protocol that specifies the kind of failures that your domain can have. No? And here, because I'm not persisting, I can call reply immediately without doing the persistent method first. And I say reply, and actually it's just that. Now, I will stop here. I'll not finish the whole live coding. But there are one important thing that I want you to understand is that in the first example, when I do then reply, I have to pass a function from state to the message that I want to reply. While in the other example, I'm not persisting, so I just do reply. And as you can see, when I pass rejected, I'm not using a function, I'm just passing the object. The difference here, and that's important to get the feel of that, is that the updated account that I'm passing there is what you get once the persisted event get persisted. So Akka take the persist instruction, and it goes to the journal, save. It's committed, okay, now it applies to your state using your event handler. Now you have an update account. It's not the balance that you have in your scope there is your previous balance. It's your previous account before applying the event. Once you apply the event, you get an updated account. So if you want to reply and you want to use the data in your or the updated data, you have to use the updated account, not the balance that's already in your scope. That's why when you go from persistent, you do persist and then reply, you get the new state. But in the other case, I'm not changing my data. I'm just decide I will just reply without persisting. So I don't need to have a function from updated state to my reply. I just pass the reply. So that's a small detail, but it's really helps you understand what is in play here. Okay, back to the, I have 15 minutes, good. Back to the presentation. Now, cluster sharding. It was always the case that the recommendation when you use Akka persistence was to use with cluster sharding. I don't think that was a message that was clearly passed to everybody, and we want it to be more obvious now. There are two separate models. You can use persistence without sharding. It works, but there are a few things that you have to solve yourself and pay attention. And of course, you can also use cluster sharding without persistence. It's not only for persistence, although it's the most common case. Lagon, if you're familiar with Lagon, it kind of takes those two, glue for you, and whenever you do persist in Lagon, when you're doing persistence event source in Lagon, it's sharded. So Lagon brings that already baked for you. So okay, Akka, you choose and you compose them. So Why shard is important? The cluster, once you make a Akka cluster, and I will not go over how it happens, there's documentation also, is material for another talk, I think. But it will manage state over different JVMs. And that's very important for persistence, because first, when you create an actor, you know that you cannot create that same actor in that same place again. You have a path to that actor and you cannot create again. So imagine that you get a request and you create that persistence actor somewhere, and then you get another request. Now you have to know if that actor is in memory or not. You don't know. Maybe there was a request arriving just before that created that actor. You don't know. So you need to put, for you, if you're not using sharding, you need to put kind of proxy around that. Another actor manage the state and know, okay, this one is in memory, this one is not in memory, I need to instantiate, and so on. So if you don't use sharding, you have to do that. But the sharding knows where is your actor. So if your account is in memory, if you shard it, the cluster shard will know where it should be in your cluster and if it's in memory or not. So it manages that for you. But why that's important for persistence is that in Akka persistence, the plugin architecture is designed for append-only journals. So you don't do a CAS operation. You cannot do optimistic locking and see if you can save the event or not. When you send an event to the journal, it just append. Why? High throughput. You do that because then you don't have to read and decide. You just append data. Of course, if I have an application and I have account in memory here, persisting, and then I create another instance of my application because I'm scaling up. Now I have two applications, and if they are not making a cluster, they are just two separated JVMs, and you can pretty much very easily bring that same account here, and the actor system in that second node will say, okay, it's not in memory, I can bring it. And then now you have twice the account, and you can send withdraw to each of them, and then they will not, you lose the consistency of your model because now each of them have an in-memory representation of your model, and they will not align. So that single writer principle is extremely important because of the append-only nature of the plugin. But if you are in a cluster, if you are scaling up your application, you need to make sure that it behaves as if it was one JVM. And the cluster shard will take that for you. Will do that for you. So that's an important aspect. And because the sharding, the cluster shard is now manage the lifecycle of your actor, it needs also to clean it up. And it's also an interesting feature because whenever you put, and not only persistent actors, everything that you put in the shard, you will be passivated after so many seconds. I think that by default is 2 minutes. And of course you can disable that, of course you can change that value, and it's programmatic. It's with a Prophet file, but you can also do programmatically in the API, which is also a huge improvement. And then at some point, if that actor is not receiving message, the shard will say, okay, that actor is nobody's sending message to it, so I may remove it from memory. So you can do housekeeping for you. So this is another reason to have it. And even if you have a single node application, we recommend to use the sharding, because when you update, if you have a single node application, you have to manage the state of your persistent actors, so you don't recreate them. You have to remove them from memory when they are not being used. And when you have to update your application, you need to bring it down and bring the new version. Because if it happens that you bring two versions at the same time in your cluster, in your Kubernetes or whatever, and if they are not forming an Akka cluster themselves, you are creating two separated instances that don't know about themselves, and they can again have that problem of the journal that I was saying, that you have two writers writing to the same journal. So even if you say I don't need to scale up my application because I don't have that requirement, it's also a good thing. Well, if you can say I'm okay to shut down my application to bring a new one, maybe you can skip this one. But otherwise, only just for a single node, rolling upgrades is also useful. And the shard will take care of that. He knows, okay, you bring a new one, the shard will say, okay, I have, let's say, 1,000 things, 1,000 actors in memory here, and sees that there is a new one, so he move a few of them to the other node, shut down here and move to the other node, and you shut down it here, so it knows, okay, now everybody should be allocated on this other node. So that's how the cluster sharding does. However, you need to have serializable commands. And please note Java serialization. In Akka 2.5 was, if you don't define a serializer, it will use the Java serialization with a big warning saying that's not a good thing to do. But in Akka 2.6, the fallback is you can use the Jackson, so it will just use JSON, but the really recommended way is to take a more efficient serialization like protobuf of Avro and so on. Why you need to serialize your commands is because if you are in a cluster and that node receives a request, you create a command and you send to an actor, but then the shard sees that this actor is not supposed to be here, but on another node, so it will send that message to the other node, but then it needs to serialize your commands. That's why you need to have serializable commands. Now, how I enable cluster sharding? That's what I will show here. I'm using event-sourced behavior for persistence, but you can do with any behavior, okay? So the first thing to do is to define what we call a type key, or entity type key. By the way, so in Akka typed, you have actor ref, but if you have an actor ref that you put in a shard, it will call it an entity ref. And that's the small difference. So you know that this entity ref can be on another node as well. So the first thing you're going to define this type key. The type key is a hint to the cluster shard to know what is the type of your message. So you're going to see why we need this one. Then I just, instead of having the behavior on my previous slides, were a string, an ID string in the behavior method that I was using as a persistence ID. But now I have to use the entity context with something that the shard will pass to me to create my event, my behavior. Now, what is, maybe it's not obvious, but what is happening here is that you'll not be anymore the one creating the behavior, creating the actor. The shard will do it for you. No? It's manage your data, it's manage your actors. So now, since I changed my code here, so now I have to tell the cluster sharding that I want this thing available. So you declare it. So when you do that, the init really means it's initiating. So when you do cluster shard init, I pass the type key. I create an entity and say, okay, that's the type key. In our case, account command is the type of our message, type key, and the behavior with that function from entity context to the behavior. The init will not instantiate your actors, because it's when you ask for a given account with a given ID that will instantiate. But it will already decide about the shard allocation. So it initializes the shards for this one. The shard regions will be there, but no actor will be in memory yet. That's why it's called init. So you put it there, but you're not yet using it. When you want to use it, you go to the cluster sharding and you say, okay, I want an entity ref for that type key and that number, account number, which, by the way, is my real account number. So that's the second key, hint of the talk. So thank you very much. No, it's not true. It's not my real one. Anyway, so the type key here is what we're going to help us to know that we need to fabricate an entity ref of the type account command. So I'm just carrying around the type information, so when you go back to the shard, you can ask for that. Then Okay, we got it. I have a demo. If we don't have questions, I can show some code. But first, the takeaways. And it's not only about Akka persistence typed, also Akka typed in general. It's a super declarative API. You discover it, you just go and you do dot, and you find what are the operations that you can do, and you build, at the end, you build a function that will run somewhere in your JVM, no? And you're gonna send message to that via the actor ref. It can be on the same JVM, and can be on another node, and then in that case, you have an entity ref, no? And that's good because you don't have this procedural API as before, and you can concentrate on the functions and the model that you have to define, and you don't have to think about if you're, of course you can still make mistakes in a business level that make introduce bugs, but you don't have to deal anymore with all those other problems that were orthogonal with the problem that you have to solve. You have types everywhere, as we have seen. You have also functions everywhere, which is a nice thing as well. Whenever someone says to you that Akka is too powerful because it's a function for any two unit running somewhere on the JVM where you even don't know where it is, well, that's part of the past. Well, it's still running somewhere that you don't know exactly where is the location of that, but it's not that function from any two units anymore. And that's the takeaways about the API. But there is also a very important aspect, which is the architectural aspect of what you can do with event sourcing. And event sourcing is what will allow you to decouple your microservice. So if a service A depends on service B, if service A needs to call service B to get some data, service B must be running. And if service A is under load, and each call in service A generates a call in service B will be under load as well. Of course, you can solve that by doing event sourcing. Of course, when you do that, you also create event consistent, and that's the trade-off that you have to choose. But event sourcing allows you to represent your mutations, your events, your domain events, in terms of events, that you can then eventually read from there, put in a broker, most common case, Kafka, so other servers can consume from there. So there is an architectural pattern that gets start to emerge when you have event sourcing. Of course, high throughput because append-only journals. The shard will give you scalability. If you need to have more instances, you scale up your shard. And it allows you to run rolling upgrades. For the shard, of course, there is something called a split brain that can happen, and there is Lightband has a commercial implementation, which is a split brain resolver, when in case you create a split brain in your cluster. But the API is open, so there are some implementations out there, and you can implement your own. But of course, I'm quite sure that the one implemented by the Akka team is super good. Sorry if it sounds a little bit commercial, but if you do that, you need to know, if you take a split brain out there, or if you decide to implement yourself, make sure you test that enough, because the one we have been tested many, many times. It's used in production, but it's commercial. One important thing, and I think I'm running out of time now, is that is not yet there, which is part of Lagon, which is distributed event consuming. When I put my events in the journal and I tag them, people usually they put one tag and then they define a singleton, a cluster singleton in one of the nodes. So in the cluster there is only one of them that will consume the events. What happens when you do that is that you have only one actor consume your events to put in Kafka or to produce views, and they will. If you have if you're consuming this stream, one for Kafka, one to produce the views, if they are in the singleton, in a cluster singleton, they will be on the same node. So that's not performant. So what Lagon does is that it will shard the tags. It will append. So if you say We want to stop calling that sharding because it creates a confusion with sharding. We're gonna probably call it from now on partition. So you tag your events, but you say that you want 10 partitions. So your tags will be account event 0, account event 1, account event 2, and so on and so on. And then Lagon takes that and creates 10 of them and distributes in the shard, in the cluster, and each of them will consume one virtual partition. That's now in Lagon, and we are moving it out. It will take some time, it's not for immediate, but we want Akka users and Play users to do the same. And so you don't have to go for the singleton solution yourself. And then it's coming. So distributed event consuming to generate views and put in Kafka and so on. That's it. The presentation is in GitHub. There is a PDF as well, because it's written in some markdown software that you can generate, but you can take the PDF yourself. And in the code there are some demos in the console. You can start the SBT console and load some files, and you can play around with that. Thank you very much.
Thank you very much.
Yeah. Have any questions?
We don't really have time for questions, but you will be around.
I will be around,
so
and
thank you
we
again.
can talk later. Thank you.